This video is on lesson 5.1 in our textbook called Number Patterns and Relationships. Chapter 5 is about algebra, and our first step is to look at things called number patterns. So for example, if I have a number pattern that says 1, 3, 9, 27, first thing we have to know is what are we going to call these numbers? The best way to refer to them is the word term. So my first term is 1. If I ask you what the second term is, you should say 3. What's the third term? 9. What's the fourth term? 27. Sometimes questions are going to go right ahead and ask you, what would the eighth term in this number pattern be? And you would have to find that out. The best way to do this in the first step is to identify your rule. What's going on here? What are the relationships between these terms? What's the relationship between 1, 3, 9, and 27? You have to identify a rule and you have to put it in a sentence. Give me a sentence. If you were to say in one sentence what's going on here with these numbers, what would you say? You can probably see from 1 to 3, you're multiplying by 3. And also from 3 to 9, you're also multiplying by 3. From 9 to 27, you're multiplying by 3. So my sentence could be, multiply each term by 3 to get the next term. Does that make sense? Go back and check. Multiply each term, my first term is 1, by 3, and you'll get the next term. If I multiply 1 and 3, do I get 3? Yes. If I multiply 3 by 3, do I get 9? Yes. If I multiply 9 by 3, do I get 27? Yes. In this way, can you find out what the eighth term in this pattern would be? You would just multiply by 3 all the way until the eighth term, and you would find out what that eighth term value should be. Sometimes you will be given two sets of numbers, such as this table right here, and you will have to identify the relationship between these two sets of numbers, or these two number patterns. We have Rico's age, and we have his sister's age. When Rico's 11, his sister is 8. When he turns 12, his sister will become 9. And so on. What's the relationship between these two patterns? You need to come up with a sentence that explains what's going on here. What's the relationship? If I were to ask you, give me a sentence and tell me the relationship between these two number patterns. Look at what's going on between 11 and 8, 12 and 9, 13 and 10, 14 and 11, 15 and 12. When Rico's 11, his sister is 8. My rule here should be to get Rico's sister's age, subtract 3 from his age. So 11 minus 3 is 8, 12 minus 3 is 9, 13 minus 3 is 10. So you can go back and make sure, does your rule make sense? Does your rule apply with the two number patterns? Is the relationship correct? If I tell you, you take Rico's age and you subtract 3 and you'll get his sister's age. Is it right? So you go back and you look at your numbers and you check. In this case, yes. It makes sense. 11 minus 3 is 8. And so on. 15 minus 3 is 12. So our rule here, our sentence makes sense. Now if my rule says, to get his sister's age, subtract 3 from Rico's age. And I ask you, how old will his sister be when Rico is 23 years old? Your answer should be, she's going to be 20 years old because 23 minus 3 is 20. How old is Rico going to be when his sister is 27 years old? You should say he's going to be 30 years old because he's 3 years older than her. So when she's 27, he'll be 30. Look at these two sets of numbers right here. You have the length of the side of a square and the perimeter of a square. When the length of one side of the square is 1 centimeter, the perimeter of the square is 4 centimeters. When the length of one side of the square is 2 centimeters, the perimeter of the square is 8 centimeters. What's the relationship here? How is the second set of numbers obtained from the first set of numbers? If you multiply each number by 4, does that make sense? 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. Go back and make sure your prediction makes sense. So I predict here that we are multiplying every number in the first set by 4, and that's how we're getting the numbers in the second set. In other words, how's the perimeter of a square related to the length of one side? If you know the formula for finding the perimeter of a square, you just add up all of its sides. So if you have a square with 1 centimeter length on each side, you just add 1 plus 1 plus 1 plus 1. If it was 2, you would add 2 4 times. If it was 3, you would add 3 4 times as well. Or you would just multiply by 4. So this makes sense. So my rule here is multiply each number in the first step by 4, and then you'll get the answers. You'll get the numbers in the second step. Or in other words, the perimeter of a square is 4 times the length of one side. Let's look at one more example. This table shows a relationship between the number of cubes used to make 2 castles. Look at the table. We have Jen's castle and Marcus's castle. When Jen's castle uses 18 cubes, Marcus's castle needs 22. When Jen's castle uses 20 cubes, Marcus's castle uses 24. When Jen's castle needs 22 cubes, Marcus's castle needs 26. First step here, part A is asking us to complete the table. How many cubes does Marcus's castle need when Jen's castle has 24 cubes and when she has 26 cubes? And then we have to write a sentence comparing the number of cubes used by Marcus with the number of cubes used by Jen. Let's find our pattern here. What's our relationship between the first set of numbers, which is Jen's castle, and the second set of numbers, which is Marcus's castle? When we have 18 cubes in Jen's castle, Marcus's castle needs 22. Just by looking at that, I know that Marcus's castle needs 4 more cubes. Is that true in the second term? Look at your second term. When Jen uses 20 cubes, Marcus's castle uses 24. Is that true still, that he needs 4 more cubes? Yes. What about the third term? When Jen needs 22 cubes, Marcus uses 26. Does my rule that I think is true, does it still hold true? That I need 4 more cubes for Marcus's castle? Yes, it's true. So for 3 terms, it turns out that we need 4 more cubes in Marcus's castle than we need in Jen's. So, let's complete the table. When Jen uses 24 cubes, how many cubes is Marcus going to need? He's going to need 28. You're going to add 4 to whatever Jen uses. When she uses 26, Marcus is going to need 30 cubes. You're going to add 4. Now, if I were to write the sentence, what would the sentence be like? It should probably say something like, Marcus needs 4 more cubes than Jen needs. Or, Jen needs 4 less cubes than Marcus needs to build his castle. You could say it either way and it would make sense.